Hello guys, myself Raghavendra SA from 3rd Sem EC department. Today I am going to explain about the topic oscillation. Introduction to oscillator RC. An oscillator RC is a type of electronic circuit that generates a continuous and repeatedly waveforms. RC standard for resistor capacitor, which are the main components using in this type of circuits. Oscillator RC circuits are commonly used in various applications such as timing circuits, signal generator, and oscillation for audio and radio frequency applications. This is the circuit diagram for oscillator RC. This is the input, this is output, and we get after the input and process, we get the waveforms of single stage and the third stage. Basic principles of oscillator RC. The basic principles of an oscillator RC circuit is based on the charging and discharging of the capacitor through a resistor. The timing constant determines by the value of resistor and capacitor, governing the frequency of the waveform generated. The charging and discharging process created a continuous oscillating of waveforms. In charging, we get the positive waveform. In discharging, we get the negative waveform. This is a circuit diagram for oscillator RC. In the circuit, it includes a resistor and three capacitor. Three resistor and three capacitor is connected to an op-amp. RC time constant. The RC time constant is measuring of how quickly the capacitor charge is discharged in a RC circuit. It is defined as the production of resistance and capacity values. The last time constant result in slower charge and discharging process leads to lower frequency waveform. RC time constant calculator. This is the formula for calculating the RC. T is equal to R into C. So we can take the formula of both resistor and transistor and capacitor. Types of oscillator RC circuits. There are various types of oscillator RC circuits, including the RC phase shift oscillator, the RC Wien bridge oscillator, and the RC relax oscillation. Each type has its own unique characters and application. The choice of oscillator RC circuit depends on the described waveforms, frequency, and other circuit requirement. RC phase shift oscillator. This is one of the type of RC oscillator RC. The RC phase shift oscillator is based on the principle of phase shift feedback. It is used in an RC network to provide phase shift to the output signal, which is then feed back to the input to the sustained oscillation. The RC phase shift oscillator is commonly used in audio applications such as tone generating and musical instrument circuits. This is a circuit diagram of RC phase shift oscillation. This is a formula for RC phase shift oscillator. F is equal to 1 by 2 pi root over 6 into RC. RC Wien bridge oscillation. The RC Wien bridge oscillation is a type of RC oscillator that used as bridge circuit with resistor and capacitor. The RC Wien bridge oscillator is widely used in audio frequency application and as sine generation. This is the formula for Wien bridge oscillation. F is equal to 1 by 2 pi RC. This includes two resistors and two capacitors. Frequency determination. The frequency of the oscillator RC circuit is determined by the values of resistor and capacitor used in circuit. The formula of calculating the frequency is given by frequency is equal to 1 by root over 2 pi RC. This is a circuit diagram of frequency determination, and it includes three resistors and three capacitor, and also the oscillators. Advantages of oscillator RC. Oscillator RC circuits are relatively simple and inexpensive to implement. They can generate a wide range of frequency, making them vice versa and various applications. RC oscillator are stable and can be provide accurate and precious waveforms. Limitations of oscillator RC. The accuracy and stability of an oscillator circuit can be affected by temperature variations and components tolerance. RC oscillator may generate harmonic dissonance due to non-linearities in charging and discharging process. The frequency range of an RC oscillator is limited by the values of resistor and capacitor used. Design consideration for RC oscillation. When designing an oscillator RC circuit, carefully selected for resistor and capacitor value in crucial for achieving and determining frequency and waveforms. Proper decoupling and shielding techniques may be required to minimize noise and their interface. Conclusion. Oscillator RC circuits are very versatile and widely used in various electronic applications. Understanding the basic principle, types, and design consideration of oscillation circuit is essential to their successful implementation. So this is all about the oscillator RC. Thank you for watching. Thank you.